So, welcome everybody to today's webinar. I'm very glad to introduce the sample preparation for food analytics to you today. So, some words up front, the webinar. You can ask us your question each time you would like to. Just type in the question here in the question window, and then we will get your question in a private chat room and answer to it. If there are some questions of more general interest, we will refer to those questions at the end of the webinar. And if we miss a question, for example, if 3, 4, 5 come in at the same time, we will go through the list afterwards and you will receive your answer anyhow then by mail today. So today it's me, Tanja Butt, product manager since 7 years here at Retsch, and Dr. Gerhard Becker's application support. He takes over the chat function and I will have the presentation. And the topics for today is homogenization, standard deviation, correct analytical values, and how to find the optimum procedure for your specific sample. I also like to tell you something about cryogenic grinding and introduce some mills which are very suitable for the homogenization of food samples with a lot of application examples. Some words about sieving, and in the end of the webinar, you will receive an email approximately 1 hour after ending of the webinar. This email arrives, and there's also 2 download links for the download package. So please just wait for this email, and then you will also get the PDF presentation, so you do not have to get each detail now or to write it down. You can just go through it afterwards with the PDF presentation. So why do we have to homogenize the sample? You know that you cannot just put a complete bar of cereal bar into an analyzer, so you have to pick part sample, and it depends where you pick the part sample, which ingredients you fetch. For example, you might just get the raisin or part of the chocolate or the other ingredients, and of course those results will not be very reproducible and they will not represent the original sample. But if you just homogenize and mill this sample and then fetch your few milligram, each part sample is the same, has the same ingredients, and the composition is the same, so you get really reliable results which represent the original sample and which are reproducible to each other. So this is then good analytical values, and you can trust those values. Just for your example, we tested this with this pizza. Pizza is very heterogeneous food sample. And we wanted to determine the fat analysis of this sample and see what standard deviation do we get with different stages of sample preparation. So we can come to this coarsely ground sample where you just find particles left over around 5 millimeters, so some of the cheese or the mushrooms. But you might think, okay, that's homogenized, I can take this for my analytics. Or you can go for a second fine grinding step and completely pulverize and homogenize the sample so that all those residues are gone. And now we can take 5 part samples, independent part samples of each, the orange, the coarse fraction, and the green, the fine fraction, and measure the fat content in the pizza. So you see the orange, the coarse fraction, varies much more in the fat content compared to the independent subsamples taken from the finely ground sample. And if we now calculate the mean value and also the relative standard deviation of the coarse and the fine pizza, we see that the standard deviation is much higher in the coarse pizza. So we can reduce the relative standard deviation in that case from more than 2% to less than 0.4%. And this is also the same, for example, this sausages. Again, we have the coarsely ground sample and the finely ground sample. And again, we see the same picture, less variations in the fine ground sample regarding the fat content and more variations regarding the fat content in the coarse sample. And again, with the mean value and the relative standard deviation in this case is really high reduction from more than 5% to less than 0.5%. So you can really influence the reproducibility by the quality of your sample preparation. And with just one grinding step, maybe the sample is not finely ground or not enough. And yeah, it's up to you to decide if this is okay. I think not. Really reliable results are just achieved with the finely ground sample with the fine grinding step. And we see this also for a lot of application examples in Duff products. Here, this tortellini, ravioli, or this filled potatoes. It's always the same. We get less standard deviation in the fine ground sample compared to the coarse fraction. And also with meat products, we see the same. Filled schnitzel, this tough bacon, or the sausage. Again, here with the tough bacon, we get the most standard deviation in the coarse sample. And you can see this for a lot of food samples in general. You can really reduce the standard deviation to a certain factor with the fine grinding step. And when we just now calculate the mean values of the standard deviation and compare it in the fine and in the coarse fraction, we see that you can just reduce it in the mean value by factor 10 when you grind it finely. And it might be also factor 3, it might be also factor 20, but the mean factor you can reduce the standard deviation is around factor 10. The working time, of course, you need a little bit more working time in the lab for the second grinding step, but it's just factor 2 or 3 time increase. And we think that's really worth it to get reliable results. Another aspect is that you can come to, not correct values when you do not do proper sample preparation. For example, here, this wheat grain, you can just analyze this unground wheat, or you can mill it up and come to this finely ground wheat sample. And again, you can take independent subsamples and analyze the fiber content via NIR analytics. And then you see that you can that you get really different results. The analytical result for the non-ground sample is here around 7% fiber content, and for the ground sample, it's around 1%. So this is not anymore a matter of standard deviation and just slight variations in the sample. It's really a matter of which value is now correct. Both values cannot be correct, so one must be wrong. And which one is wrong? We have to have a closer look to the analytic measurement. With NIR, you only measure approximately 1 millimeter depth. And in the case of the unground sample, you just measure the outside, the shell of this grain. And of course, there's a lot of fiber in. And the starch content is more in the middle, but you do not see this because the measurement depth is just 1 millimeter. So you get really false result when you do not grind this up and also see the inner part and the core of this grain. Yeah. So here, sample preparation leads to correct analytical values. So important questions for you to find the optimum procedure, the correct mill, and the best parameters for your specific sample is what are my sample properties? Humid, fibrous, tough, sticky, temperature sensitive. You have to know that. Then very important is the initial particle size and which final fineness is required. Then it gives you already a hint which mill is suitable for your sample and which not. And also the sample amount is very important to find the correct mill and the correct accessories. How many samples a week? Subsequent analytics is very important. And also an aspect is which you have to consider is drying or embrittlement of the sample allowed. Grinding at room temperature is can be done. That works, but it makes it easier in the lab if you are allowed to dry a sample or if you are allowed to embrittle a sample in some cases. Of course, when you have to analyze for the humidity of a sample, drying is not a good idea. So you have to keep in mind what I said before, the subsequent analytics. And also it depends on the regulations in your lab if you're allowed to embrittle a sample or not. The advantages of embrittling the samples will be seen hopefully clearly in the presentation. And what is meant with cryogenic grinding? Cryogenic grinding is a particle size reduction or homogenization at very low temperatures. Here we are talking about minus 196 degrees when we are working with liquid nitrogen, or still pretty cold when we are working with dry ice, minus 78 degrees. So here, everything which is immersed or mixed with dry ice or immersed in liquid nitrogen gets deeply frozen, and then it doesn't stick anymore. So this is beneficial for sticky and fatty food samples, and then you pulverize the sample instead of making pastes at room temperature. For example, here with this chocolate. And we can also here see what happens when we compare just the fat results for the spring rolls. We did it in the same way you already know, coarse and fine fraction at room temperature, or we can just grind it up cryogenically in the GM200. Here we also need 2 grinding steps, which can be just done one after each other. 15 seconds in the reverse mode. So we use the blunt end of the rotating knives in this mill to have an impact event. We cannot cut a hard frozen sample in the beginning. So the sharp side of the rotating knife doesn't help us in the beginning. So we have to pre-cut it or crush it with the impact mode. And then we can use the full speed in a second grinding step, in the fine grinding step, and come to similar results than the sample size reduction at room temperature. And now if we measure again the fat content and the standard deviation, we see that we come to similar results in the fine ground sample, whether it was done at room temperature or cryogenically. But the advantages of cryogenically or cryogenic grinding is at room temperature you achieve pasty samples like this, and this sticks. So what happens in a knife mill? The knife just rotates, and the sample is, at a certain stage very sticky and sticks to the wall of the grinding container just above or below the rotating knife. So the rotating knife is just kind of a funnel formation where no sample is hit anymore. And if you do not mix this manually in between or add a little bit of water to improve the mixing, then the grinding effect is less. But if the sample is frozen, it doesn't stick anymore. So you do not have this funnel formation. You have mixing effect just by the grinding process itself, and you do not have to reopen it and to mix it manually. Yeah, so that is also a very nice advantage of cryogenic milling. So let's go on. I'd like to introduce some knife mills for sample homogenization. So knife mills are designed for moist, fatty, stick, tough fiber samples, which is in terms food. So it's perfect mill for food. The maximum feed size is around 40 millimeter in case of the smaller systems, GM200. And we have also a larger system, GM300. Here, the maximum feed size is up to 130 millimeter, but it depends a little bit on the sample. If you go for cryogenic grinding, we also advise just go for maximum 40 millimeter also in the larger system. At room temperature, you will produce homogeneous paste, and for granular samples like grain, you will get approximately final fineness around 2 millimeter. Dry ice can be used for cryogenic grinding in both systems. You will see this later on. And we have autoclavable accessories for both systems, and we can store standard operation procedures. With the GM200, we can also operate in program sequences. So a coarse grinding and a fine grinding step can be just combined, and you only have to click one time to run the machine. You will see this. The functional principle is, you know this from household mixer system, but it's really a very a tough lab machine. It's not just a household mixer. The quality of the sample preparation is much better than in a household mixer because we have more options, more accessories, which are really designed for sample preparation. It's CE qualified. And it's really a lab device and not just a household mixer, which is maybe broken after 50 samples, something like this. So here with this system, it lasts for several years. And if you have a closer look to the GM200, the touch display here, you can just put each parameter simply by touching and rotating knob, and you can just set here the parameters like speed, time, cutting, or reverse mode, and if you use intervals or not. And as I said before, we can store sequences parameter set A and B, where you just define all the 4 parameters, and then it's just one after each other with just one click. And when you come back, the coarse and the fine grinding step has taken place. So I think this is a very comfortable system for your samples. When we now start with the application examples, let's start with chocolate, vanilla pods or chips. In the GM200, we pre-cut this to 20 millimeter sample. And then we use the standard accessories, 1 liter polycarbonate grinding container, standard knife, and the standard lid at different speeds for the samples. And 10 to 30 seconds each, we were able to homogenize a sample to approximately 2 millimeter. In case of the chips, it was more 5 millimeter. The question is, what about food, which is containing very high water content, such as tomatoes? Tomatoes, you know, it's more or less water. And yeah, this might cause problems when you really like to get it homogeneously ground. You can do this in the GM200, but here we do not use the standard lid anymore. We exchange the equipment with the gravity lid with overflow channels. This lid over here is a gravity lid with overflow channels. What is done, you just put it into the grinding container, and at the beginning the tomatoes they take yeah, a lot of volume, and while you start to grind the tomatoes, the volume shrinks, and this lid just follows the volume and just presses the sample against the rotating knife and makes it more efficient grinding. And what happens as well, you have a very liquid sample. So due to capillary forces, some sample will just climb up here between the lid and the grinding wall and will spill out over here. But we avoid this with this overflow channels. Here, the sample is just led back to the center and still ground by the rotating knife. So this lid helps really to get a better result and to come to this finely ground sample. We do this in 2 grinding steps. In the first step with less speed, and then in the second step for another 10 seconds, we increase the speed to 8,000 RPM in this case. The question now is, what can we do with samples which are not having that high water content, but which are only a little bit moist? For example, with vegetables. Here, slightly humid sample, that means the sample tends to stick, as I told you before. So we can use the same equipment in the GM200 as for the tomatoes. Then in the second grinding step, it's necessary to add a little bit water to increase the homogeneity and the sample mixing, because here this coarse ground sample tends to stick just above or below the rotating knife, and then you get the funnel formation. Or you can reopen the container and mix it manually for several times, but this is also annoying, so adding a little bit of water helps greatly. And here again, fine and coarse grinding step for each 30 seconds. Increased sample amounts can be done in the larger system, the GM300, like this whole grapefruits, apples, or the lettuce. Here again, standard equipment, 5 liter polycarbonate container, standard knife, and the gravity lid for the GM300 at almost maximum speed. In less than 30 seconds, we were able to produce the homogeneous samples. In case of the apples, here we had also to add some waters to improve the homogeneity. Dry and fluffy samples like this bread can also be done. This complete bread was put into the GM300 with the standard equipment. So here we need the standard lid. So we really need some room in the beginning to have enough place for the sample. At medium speed, 15 seconds, and the sample is homogenized to 2 millimeter particles. Very sticky samples, and also maybe a task which you face in your labs is heavy metal free grinding. So if you analyze your sample for heavy metals, you need to work with tools which do not increase the heavy metal content in your sample by abrasion. We have always some abrasion when we grind sample. So a little bit of the rotating knife, yeah, there is abrasion, and you will find this in your sample afterwards, not in the range that you find some splinters of the knives, but in the ppm range, you will maybe increase their heavy metal content when you use steel blades of your sample. You can avoid that So you cannot avoid abrasion, but you can determine or you can influence the kind of abrasion. If you look for heavy metals, then you should avoid using steel equipment, and you can use, for example, a knife with blades of pure titanium. Then you will get this titanium abrasion, but this does not disturb your analytics. And then we use another lid, not the volume, the gravity lid, which I introduced before, but we use the volume reduction lid, 0.25 liter. So this sample is sticky, but it doesn't lose the volume too much or very much during the grinding process. So you can just put this lid from the beginning on and press the sample towards the knife. And as it has not very high water content, you do not need any overflow channels or something like this. So just press the sample against the rotating knife to avoid any sticking above or below the knife. And then in 10 seconds, we were able to get this really sticky paste, this homogeneous paste of this resin. And we do not have any heavy metal contamination through abrasion. What happens, what we cannot completely avoid, is that there might be some residues. So half-cut resin, or maybe a resin which was cut 3 times but not completely homogenized, swims just around in the sticky mass and is not hit anymore by the knife. Yeah, you will maybe find those residues, and yeah, it's really tough to get rid of it at room temperature. When you like to get rid of it, you have to do it cryogenically, as you will see that in the following slides. But what about very sticky, fatty, or tough samples? For example, this fish or this tough bacon. It has no scales, it has fish bones, it has very tough skin. And here samples preparation might be a little bit challenging in some cases, but with the right equipment and the know-how to do it, then it's still easy. So in this case, we change the mill, not the mill, the knife. We take the knife with serrated blades. They are looking like this here. So it's not just the smooth surface anymore, but it has this serrated blades. And you can imagine what happens. It just tears apart the tough skin. So it's really nice knife for such kind of samples. And here another trick is used. We take 2 different lids. In the coarse grinding step, we take the standard lid. So we have a little bit room for the sample to move, and can just go for the coarse grinding step. And then we exchange the lid by the volume reduction lid in the fine grinding step, and then press the sample towards the knife and can come to this finely ground sample. If we take this volume reduction lid from the beginning on for such a tough sample, then it's too much pressure on the knife and you will just block and stop the mill. But with the first lid, the standard lid, everything is fine. And the second step, you can use more pressure on the sample with the volume reduction lid. So here we come to the sample, but again, some remainings are left over, scales maybe, or some fish bones. Can we avoid such residues? Not really, at room temperature at least, but we can greatly influence it by the choice of the correct equipment. Here, just for your example, a sample ground with the standard knife or in the same conditions with the serrated blade knife. You see with the standard knife, there are large lumps left over from this tough skin, and they are almost gone when I use the serrated blades. So just using the correct equipment, you can greatly influence the quality of your sample preparation. And now I'd like also to give some examples for cryogenic grinding in the knife mills. Cryogenic grinding in GM200 and in GM300 is allowed. We use dry ice for that reason. Liquid nitrogen is too cold for the bearings and sealings, so please stay to the dry ice. And what is very important that we should avoid any accessories which contain plastic parts. So here the standard knives and maybe the standard polycarbonate containers, they will be embrittled as well when we embrittle the sample and transfer the mixture of dry ice and sample to the grinding container. And hard frozen plastic may break during grinding process. So this is maybe not the best idea. Might not break in the first or in the second grinding, maybe in the 10th, but a certain time it will break. So it's more fun to use the steel equipment, steel grinding container and full metal knife, and then you really have good quality, and this cannot be embrittled and will last for a long time. So there are also videos which show the cryogenic grinding in the GM300 and GM200, which are included in the download package. So here we can only show some screenshots. Um, and the procedure is the following. You mix a sample with the dry ice here, for example, here, the raisins in a ratio 1:2, and important rear protective gloves and glasses for your own protection. Then you have to wait for 1 or 2 minutes until the sample is pretty cold, transfer the complete mixture to the grinding container and start the grinding. And as I said before, the sample now is hard frozen, so you cannot cut it. So it makes no sense in the first step to use the sharp side of the knife. So you go just in the reverse mode and use the blunt end of the knife to have impact and to crush the sample in the first step. And then in the second step, use full speed with the with the sharp side. Also very important, dry ice is frozen carbon dioxide, and when you have a little bit warming during grinding process, it tends to evaporate, and yeah, this will increase the pressure in the grinding container when it is closed. So we have to use a lid which has openings so that the carbon dioxide can just leave the container and will not lead to overpressure. So this is what the sample looks like. For the grinding process, just pulverized raisins and not sticky sample material anymore. The same can be done in the GM200. So here we allow cryogenic grinding since August this year when we launched the cryo kit containing a stainless steel container with buffers for improved mixing, the full metal knife here with 4 blades and a specific cryolid. Then we can, yeah, again, see some examples. The sweets, which are just sticky at room temperature, but they are not sticky anymore when you just freeze them. Then we can use the 5-liter grinding container, stainless steel, full metal knife, and the lid for cryogenic grinding in the GM300 due to the sample amount. So we also have room for some dry ice. And the reverse mode in the coarse grinding step and forward mode in the fine grinding step, each 10 seconds, we were able to get homogeneous samples. Cryogenic grinding of moist samples, fruits and vegetables, yes, we can do this. In that case, customer didn't want to add some water because of dilution effects. So here the method of choice was cryogenic grinding. And we did it in the GM200 with the cryo kit containing the stainless steel container with baffles, full metal knife with 4 blades and the cryolid. Again, dry ice, reverse and forward mode, each of 30 seconds and 300 micron particles. Cryogenic grinding of fatty samples is also possible, like this marzipan cakes or chocolate. Similar conditions, 20 seconds for each grinding step, and then we were able to homogenize this fatty samples as well. So the advantages of cryogenic grinding: in the case of carrots, we do not have to add some water or to mix it manually in between, so no dilution effects. In the case of raisins, we are sure that there are no leftovers just swimming in this sticky sample. So we get complete homogeneity. And for this chocolate with the nuts, we see it directly that we can get rid of all this nut residues here. So it's complete pulverization when we do it cryogenically. If we have only small sample volume, we can still work with the GM200. Here, some seeds, only 40 gram or 70 gram of this nuts, or just some pieces of the sticky cheese. Here, standard equipment and the volume reduction lid, which forces the sample downwards and doesn't allow the sample just to fly around anywhere, but not where the rotating knife is. And after just 20 seconds, it was homogenized. In the case of the sticky cheese, we had to open it after each 10 seconds and to mix it manually with a spoon. And just to give you this example in a more detailed way with the standard lid and the volume reduction lid. Here we have just 50 gram seeds, 5 seconds, ground with the standard lid, and you see there are leftovers, unground sample because it was not hit by the knife. It was just flying above somewhere in the grinding chamber. And with the volume reduction lid, you reduce the volume, you reduce the option to escape from the knife, and it's hit more efficiently, and all the residues are left. So again, an example with the correct choice of equipment, you can greatly influence the homogeneity. What about very small samples? Now I think it's time to change the mill and talk about mixer mills and cryo mills. Here I'd like to refer to 3 different systems. The MM400, which is well known and kind of all-rounder in the labs, and the MM500 Vario, which has been launched in summer this year. Here we are talking about sample volumes up to 20 milliliter in each grinding jar. We have maximum feed size of up to 8 millimeter sample, and typical fineness for food sample is around 100 to 400 microns. You can also use single-use vials in different volumes, up to 50 milliliter in the case of MM400 and up to 5 milliliter in the case of MM500 Vario. And also we can work cryogenically with a cryo kit. The advantage of the MM500 is that you have very high throughput with 6 grinding stations, so 6 samples in one time can be processed, and it has a little bit more power, 35 hertz compared to 30 hertz of the classic mixer mill MM400, and this leads to faster grinding results, of course. The cryo mill is a system where you usually work cryogenically with the use of liquid nitrogen. And here you use the autofill system for enhanced safety. There's no open bath with liquid nitrogen required. And it gives you also the options to work with grinding cycles and programmable cooling times. You will see this later on in the slides. So working principle of this kind of mill is just horizontal movement, shaking of the grinding jars, which contain usually one large grinding ball. So when you have a sample in this, the sample is just crushed by impact when you move this grinding jars very quickly with up to 30 or 35 hertz. And a typical sample for that kind of mill is dried peas like that, only a very small amount, 6.5 grams. It's just done in the MM400 in the 50 milliliter grinding jar, stainless steel with one large ball, 25 millimeter, frequency 30 hertz, just 30 seconds, and we come to 0.4 millimeter particles. If we like to work without the abrasion of any heavy metals, as in the example with the GM, we can also use here different grinding jars, for example, with the zirconium oxide inlay or tungsten carbide inlay. And we can also adapt the volume of the sample by choosing smaller grinding jars with less volume. So here everything is fine. And the question now is, if we have many samples a day, we can of course use the MM400 with the 2 grinding stations, or as I told you before, the new system, the MM500 Vario, for example, 6 times 8 grams of those kind of samples, dried hibiscus, fish or corn. Then we use 6 grinding jars and 6 times this grinding ball, of course, increased frequency, and in 1.5 minutes we were able to really get a very fine powder of 1 millimeter. If we have only one single grain, just one of this corn, for analytics, we can put it in a very small grinding jar and grind it as we are used to, but maybe grinding process is fine, but sample recovery gets a little bit difficult because you will have this powdered sample covering the grinding jar inside and the ball, and then it gets a little bit tricky to get the sample back. But if we use a single-use vial like this 2 milliliter Eppendorf tubes, then that's very easy. And we do not have the risk of cross-contamination because the tubes are just used one time and then thrown away afterwards. So for DNA, RNA, this is quite nice. If you are using to extract the sample for DNA or RNA, then this is a good system. We use adapters where we put these tubes in, and we have different adapters, a large one where 10 of these 2 milliliter tubes fit in, or smaller ones where 5 can be put in. And now we can put these adapters into, for example, the MM500 Vario several times, 4 of those large ones plus 2 of these smaller ones. In total, we come to 50 tubes which can be placed in. And of course, then we need, of course, 50 times a grinding board, 7 millimeter, which is placed into this tube. And then with a medium frequency, 30 hertz, not full speed, we were able to reduce this sample to fine powder. So 50 samples in just 3 minutes. It's very high sample throughput. Fatty or moist samples in a grinding jar. This can be done, but it's maybe not fun. It's just smashing the sample, awful sticking, maybe not nice cleaning, and the homogeneity is also a little bit under question. But if we do it cryogenically, we can come to pulverized samples also in mixer mills very nicely. Here it's very important that we work with indirect embrittlement. So we do not fill any cooling agent into a grinding jar and close that. This would lead to severe overpressure. But what we are doing, we put the sample and the grinding board into the jar, we close this, and then we take the closed jar and put it into a bath with liquid nitrogen. And we wait until the liquid nitrogen stops boiling. And then that's the case that the sample inside is also frozen, and we can start with the grinding process for at least 1 or 2 minutes. And then we maybe need some intermediate cooling in the grinding, in the liquid nitrogen bath if longer grinding times than 1 or 2 minutes are required. Very important, please only use stainless steel equipment, not the zirconium oxide jars, for example, as the very cold temperatures would lead to different behavior of the zirconium inlay compared to this stainless steel jacket. This will cause some wear over time. So we just recommend to use stainless steel equipment for cryogenic grinding in a mixer mill. It's also video included in the download package where you get all this information again. Application example, chewing gum, sweets or raisin, MM400 cryo kit, embrittle for 3 minutes in this liquid nitrogen bath, stainless steel equipment, 30 hertz, 30 seconds, and pulverized sample. If we like to avoid the bath with liquid nitrogen, might be a security reason in your labs or maybe personal preference, then we can work with a cryomill, which works with this autofill system. So here the liquid nitrogen is automatically flushed in this jar holding position where the jar is just clamped in. It's still indirect embrittlement of the sample, but the advantage is that you do not have contact to any liquid nitrogen at any time. What comes out at the mill at the rear side is just evaporated nitrogen, and it's a very safe system. And it also allows you to program cycles and to program the pre-cooling time, and it's more reproducible than just waiting until this liquid nitrogen bath stops boiling and then take over the sample into the mill and so on. So it gives you a little bit more options in the programming. Praline or cheese is a nice example. Here again, stainless steel grinding jars, boards, automatic pre-cooling 3 minutes, and 2 minutes the sample were just pulverized. If we compare it again to the MM400, we do not have any contact to the liquid nitrogen thanks to the autofill system. And if we have tougher sticky samples like this licorice or this meat, maybe this is not done in just 2 minutes grinding. It needs a little bit more grinding time. Here with the cryomill, we can just increase the time for the pre-embrittlement to 5 minutes. And then we can work in so-called cycles, which means we grind the sample 1 minute at 30 hertz, and then we interrupt it for 1 minute at 5 hertz. We just slightly move the sample inside that it doesn't freeze with the board, so it's just movable. And we repeat this cycle 3 times. And in total, then it's 1, 2 times 3 times. It's up to 6 minutes grinding time in total, or process time, plus the 5 minutes and 11 minutes we were able to crush the sample. And it's very reproducible because we do not have to fetch the sample, take it out, put it into the bath again, and so on. What about larger sample quantities? Then it's time to talk about another type of mill, rotomills. Here, rotomills, we are working with a defined final fineness. For food, we're talking about around 100 microns, which can be achieved. We can cool the sample thanks to an optional cyclone. We can use variable speeds. It's suitable for cryogenic grinding, at least two of the mills I'd like to introduce. And we can work with an optional feeding system for the ZM200 and the SR300. What is the ZM200 is the ultracentrifugal here. It's kind of all-rounder for sample preparation, and for food, it's used for slightly fatty granular samples, corn seeds, sugar like that. Fresh tomato or some fresh vegetables is maybe not the best idea to put this in. This will be only awful, a smashed sample, not homogeneously, and the cleaning effort will not be nice. So it must be granular samples like corn or seeds. Up to 5 liter in one batch, and maximum feed size is 10 millimeter. Larger system is a rotor beta mill SR300 for sample amounts up to 26 liter and a maximum feed size 25 millimeter. So feedstuff pellets can be ground here as well. And specifically designed for NIR analysis is cyclone mill twister, which is for really non-fatty samples. Fatty samples will block it. Maximum feed size 10 millimeter, and it is designed for keeping this collecting bottles 250 milliliter here, which are clamped very quickly, so you can come to a high sample throughput by just exchanging the sample bottles quickly and to grind one sample after each other, and it's a very cost-efficient model. The working principle of all the rotor mills is the same. The sample hits the rotor, then it's accelerated towards this rotating teeth, and it's just crushed by impact. And if it's not fine enough to just pass the purchase of this ring sieve, then it's just further crushed by shearing forces, and then it's collected here in a collecting pan, cassette, or in a receptacle. Typical example for ZM200 is tea or ginseng roots, which is fiber samples, and here the requirement was very fine fineness and no warming allowed. So we use the fully equipped ZM200 with the cyclone system. Cyclone here, imagine you attach a vacuum cleaner over here, and then it generates an airstream through the grinding chamber, through the grinding cassette, and here to the cyclone. The sample and the air is separated. The air is just going into the vacuum cleaner, and the sample is just put here, collected in the collecting receptacle. And this airstream helps to discharge the sample from the grinding chamber. And of course, you have a cooling effect by the airstream, like a cold wind. And for larger sample amounts, we can use the automatic feeding system over here, where the sample is just fed automatically to the mill. We use the 0.2 milliliter ring sieve, the standard 12-tooth rotor, and the cyclone. Maximum speed 2 minutes, 150 microns. So here, with this fiber samples, the standard ring sieve is very beneficial because we need the shearing forces. Fatty or oily samples, oil seeds. Here we use a distance sieve, not the ring sieve anymore. If we use a ring sieve, it will look like this. The shearing force would lead to just greasing the sample and release of fat particles and the blocking of the aperture sizes of the sieves, and then this is not efficient anymore. But if we reduce the shearing forces because we just make the sieve a little bit larger in the diameter, so it gets a little bit room left here between the tooth and the ring sieve or the sieve itself, then shearing forces are reduced, fat release is reduced, and we can come to a pulverized sample. And we also have less warming than with the standard sieves. Temperature reduction is only possible with the distance sieves in the ZM200. Now we have also some other options. We can play around with the speed. So we do not have always to go for our 18,000 RPM. We can also use reduced speed, like in this case, 12,000 RPM for samples like corn, cocoa, or pistachios, which are very fatty. Different distance sieves have been used, and in 2 minutes, this amount of sample was just crushed. What happens with such fatty samples, cannot completely avoid that, is that you have this fat particles, this fat balls just rolling around. You have to mix the sample afterwards to get a really homogeneous samples, but it has been crushed completely. And if you have such fatty sticking samples, just open the mill, mix it with a spoon, close the mill, and start the crushing for some minutes, some seconds, usually 20-30 seconds again, and then the sample is just blown into the collecting receptacle. Heavy metal free grinding is also possible. We use then equipment which is made of titanium or titanium niob coated cassette. So we avoid steel equipment, as in the example before with the mixer mill. That's also possible on the ZM200. For example, this ground coffee. Sieves with smaller purchase sizes are also available for the ZM200, but maybe not best choice for each sample. So forcing a coffee fatty sample through an 0.08 millimeter sieve, this will not work. Yeah, but for samples like gelatine or sugar, this can be a good option because the sample is already very fine and it's not fatty. So this can be maybe forced through this 0.0 8 millimeter sieve or 0.25 millimeter sieve. This can work. So here the cyclone was used to have this cooling option and to have better sample discharge. And we need a little bit time, so we put the sample or pour the sample slowly into the machine, but at maximum speed to really force it through this very fine sieve. And in the case of the sugar, we got 30 micron particles here. Cryogenic grinding can be done. Here we like to mix the sample with dry ice, as for the GM. For the example, this dried algae, and then we can go for cryogenic grinding. The sample, is cooled during the grinding process, thanks to the dry ice. We use maximum speed to have it quickly ground in the grinding chamber and to have it less time ground as possible to avoid any warming. But the feeding time must be a little bit slower than maybe at room temperature, or samples which can be ground at room temperature, so that the sample does not warm during the grinding process because it stays too long in the grinding chamber. What about very high sample throughput? For example, NRR analytics, I told you before. Here, so cereals, crop, tobacco, that's very non-fatty samples, which can be ground in the cyclone mill twister. And here, 4 times 150 grams of each sample had to be ground. So 12 samples in total, and here with the cyclone twister, we were able to do this in just 3 minutes. So 1 minute for each 4 sample of the different types. So here we can come to very high sample throughput because of the quick bottle exchange and the quick grinding process. If we have larger sample size and volumes, then it's time to change again the mill, talk about the SR300, so the larger sister of the ZM200. Example is here 1 kg of spices and herbs for pesticide analytics. It's a very light material, so they have very large sample volume and up to 25 millimeter initial particle size here. So it's perfectly suited for the SR300. We took 15 minutes for each of this 1 kg samples. It takes a little bit time to bring the large sample volume through the system, but I think 15 minutes is okay. And 0.25 millimeter was the result. Other samples like this rock salt can also be crushed in a SR300. It's also an abrasive material, and again, large sample pieces up to 25 millimeter. Here we use a distance rotor in the SR300. Distance rotor has the same effect than a distance sieve in the ZM200. We reduce the shearing forces, but here in this case, we just reduce the diameter of the rotor and do not increase the diameter of the sieve as in the ZM200. So we get less warming, less shearing forces, and we need the crushing effect. So we can just do this 5 kg in just 6 minutes in the SR300. When I like to have or grind samples with very large initial sizes, then we have to talk about cutting mills, another type of mill. Cutting mills here, I'd like to introduce SM300 and 400. Here we are talking about pre-grinding the samples. Medium hard fibers and tough samples can be ground in that system. And for food samples, it's usually 1 to 10 millimeter. So it's not fine grinding. Usually we need a second mill to come to really finely ground sample. It's for pre-crushing the very large initial samples. Up to 26 liter per batch, we get a defined final fineness, and we can cool the sample with a cyclone if required. And here we are talking about SM300. Maximum feed size is 60 times 80 millimeters, so much larger than with the SR, with maximum 25 millimeter. Very efficient grinding because we have double acting cutting bars and a maximum peak power up to 20 kilowatt, which is required, for example, hard frozen samples. You will see this later on. By choosing different rotors, we can working in a shredding, chopping, or cutting mode. And I think very interesting for food samples, we have a 316L stainless steel food grade version available for small scale food production processes. We have a variable speed in the case of the SM300 and push fit rotors for easy cleaning and exchanging the tools. If we really have large samples, the SM400 can be used, feed size up to 170 times 220 millimeter. Very large hopper opening and a large bottom sieve. We can also work with the optional continuous outlet, and we work with chopping mode at 280 RPM, so a fixed speed. Grinding principle is, I think, also well known. Sample is here just a cut between the rotating rotor with the knives, and then it's cut between the knives and the cutting bars here in the grinding chamber. And when it's fine enough to fit to the through the aperture sizes of the bottom sieve, then it's collected. So, for example, cocoa cake up to 80 millimeter was crushed in the SM300 using the parallel section rotor. That's this one over here with the 3 blades. And yeah, this worked fine. Just in 1 minute, we were able to crush 1 kg of the large sample up to a fineness 10 millimeter. And the cyclone can also be used to cool the sample. What you see here when you open the mill after grinding is that some sample sticks to the grinding chamber, to the rotor, to the door, because of the fatty parts of this sample. When you now like to clean this, you can try to take a brush and a vacuum cleaner, but sticking, it's not fun. What we recommend in such case, just close the door, take some dry noodles and grind just the dry noodles in a cleaning step. The dry noodles are abrasive and scratch the sample from the tool, from the grinding chamber, from the door. And what is left over is just powder of dry noodles, which can be just removed with a brush and a vacuum cleaner afterwards. And then the sample, the mill is ready for the next sample. Finer is not possible is the question over here. As I told you before, the cutting mills are used for pre-crushing sample, but we can go slightly or a bit finer depending on the sample. So in this case, dried fish, it was freeze-dried fish, very tough and really fatty. And here the customer asked us, hey, can we maybe do this in 1 mill? Can we try this? And then we tried and used the SM300, I'm sorry, with the V rotor. So we exchanged the equipment to this rotor, which has 5 blades, and the blades are designed in a way that it is more working like scissors and then in a kind of chopping the system. So you really cut it. And for this fibrous, tough material, this worked fine. And a cyclone to cool the sample and to have better sample discharge and to force it through the 0.75 millimeter bottom sieve. In 2 minutes for this 4 freeze-dried fish, we were able to get very nice fineness less than 1 millimeter. And we did not have any fat release thanks to the grinding mode, and the V rotor is also very useful to reduce warming effects. So for fatty sample materials in that case. When do we reduce the speed? We tend to you reduce the speed in cutting mills when we like to reduce warming effects or when we like to reduce the fine fraction in the ground sample. Here the customer asks us, I'd like to have small scale production of poultry feed, so I need something between 2 and 6 millimeter after grinding. Chicken do not like to pick up a powder and they do not like to eat the whole grain, so somewhere the middle fraction is required. And then we use the SM300 with reduced speed. One option is to reduce it to 700 RPM, and then we find that little bit sample is here in the required fraction between 2 and 6 millimeter. It's about 30% of the complete sample, but most of the sample is finer than that. 1 millimeter, 0.5 millimeter, or still powdered. When we use 700, when we reduce it further until we come to this 100 RPM shown here in yellow, we see that we bring more fraction into that. Only a very small percentage of the sample is smaller than 2 millimeters. So more than 95% were brought into the required fraction. And this was really nice for the customer, but he told us he liked to grind up to 25 kg. And 25 kg into the SM300 is maybe time consuming. So we also tried the SM400 where we have large hopper opening and the large bottom sieve. And we also working with low speed, 280 RPM. And in that case, it was fine. It was still more than 60% in the required fraction. And it only took us 3.5 minutes to grind up this 25 kg of corn, of maize. So the customer was very happy with the SM400. Hard and tough sample and reduce speed. Also we can grind this in the SM300. For example, this complete frozen fish. It's hard frozen and has a length 30 centimeter. About 20 millimeter particles were required. So here we had changed the equipment. We use a different hopper for the SM300. We take the long stock hopper. So here's just the hard frozen fish can be inserted quickly to the mill, very nicely. And we use a 6-disc rotor. I show you the rotor in the next slide, which is very robust rotor and can cope with this hard block of material. So the fish is not smooth anymore. It's really like a wooden block. And here cutting is maybe not the best. We need shredding, and then the 6-disc rotor is used. Here we take 700 RPM to avoid any warming of the fish during the grinding process. Warm fish in such a machine is maybe not a nice idea, also for the cleaning afterwards, but with a hard frozen sample and reduced speed, that worked fine. Harder materials than frozen fish can also be ground, like this hazelnuts with the shell. And here again, we have to use the robust rotor. Of course, it's the 6-disc rotor, which works like shredding. Here we have in total 18 of those discs, which do not have a sharp side anymore, but we need the shredding option and very robust mode of action to crush the hard samples. And here with this 4 millimeter bottom sieve, we are able to crush those hazelnuts as well. We can use sieves with less aperture size than 4 millimeter, but in this case of the fatty samples, it's maybe not the best option. Why? The sample would be squeezed too much and the fat release would block the bottom sieve with a less aperture size than 4 millimeter. So 4 millimeter, 6 millimeter, that's good for such kind of samples. Then I told you that we have the SM300 and a 316L food grade version. Here we were asked to grind 100 kg of cannabis each day for a food and medical treatment, and we designed this SM300 in a food grade version with this long stock hopper, and everything is made of 316L, the grinding chamber, the hopper, the bottom sieve, the rotor, and so on. So every touching part of this mill is 316L. And indeed, we were able to have a maximum feed size or the throughput of this sample 20 kg per hour. So in 5 hours, we were able to grind the 100 kg of this plant material to 4 millimeter size for small scale production. And if now the task is for the food industry, hey, it's nice to get 4 millimeter particles or maybe 2 millimeter particles in a cutting mill, but if we really like to grind it finely to get a fine ground powder, but also 316L, what options do we have there? And we can use a different mill. That's a drum mill TM500. Here we have 2 options available, the standard option and the 316L food grade version. This was launched this year as well. And yeah, it's a ball mill again. Here we grind up the sample with ball mills, which are required for fine grinding. We have a very large drum, 150 liters, and it allows us to put in 35 liter per batch of sample with a maximum feed size 20 millimeter. It's really able to pulverize the sample with a different or variation in speed. It's yeah, able to be adapted specifically to your samples. And we can work with this optional sieve section to separate the large sample amount with the 80 kg balls. Doing this manually afterwards would be time consuming, but with this sieve section, this works fine. And here I have also an example, the last grinding example, genuine roots, 20 liters, and with the TM500 C16 food grade, 80 kg balls of 30 millimeters each. Yeah, in just 1 hour at 50 RPM, we were able to grind this 20 liter sample to very nice fineness of 130 micrometers. So this is really for pulverization food grade level. So I've left some minutes for the presentation, and besides homogenization, what else can Retsch offer for the food industry, food analytics? We can talk about sieving. Here I can only really quickly go through the most important points, just make a little bit of appetizer to our sieving webinar, which has been recorded recently and is available on our webpage. This webinar is just dealing 1 hour just with sieving, each sieve shaker and all the tips and tricks around sieving processes. So if you're interested in this, please watch that recorded webinar. Here in this webinar, it's only time to refer to the most important points. So we have in our portfolio 9 sieving machines, and they can be grouped with the mode of sieving. The most common one is the 3D vibration sieving. As for the AS200 series, and the largest system AS300 control, or the largest system AS450 basic and control. We also offer a machine for tap sieving or airstream jet sieving, and one machine for horizontal movement of the samples. And yeah, of course, we are working with sieve stacks to come to a different fraction. The mesh size becomes finer from top to the bottom of such a sieve stack. For example, this is a classic sieve stack where you can separate the particles from 4 millimeter to the powder, which is collected in the collecting pan. And a question what we receive frequently is, how much sample can I load onto a sieve? And here we have a rough equation which helps you to determine how much sample can be put on a specific sieve. Here you have to know the diameter of the sieve. For example, for the AS200 series, the diameter is 200 millimeter. For the larger systems, goes up to 450 millimeter diameter sieve. Of course, this can keep more sample than a smaller diameter sieve. So you need also to take into account the mesh size and the material density. And then you can calculate it just, and what comes out is the maximum remainder, which is permitted on a sieve after the sieving process. So how much material can be collected as a fraction after the sieving process on a specific sieve. And the load is just double that remainder. So twice as much sample can be loaded to the sieve in the beginning. And if you do not take this into account, then it has two effects. You can damage the sieves with very fine aperture sizes because the mesh wire is not that durable. Or what is more important to my mind is that you will come to non-effective sieving, because here the sieve is completely blocked by these large particles, which are the remainder afterwards. But the fine particles, they cannot really come through the sieve. So there's no chance that here is an effective sieving anymore, because there's too much material on that sieve, and it would come to false fraction, because those particles are much finer in reality and not considered to be on that sieve anymore. And how do I calculate such a particle size distribution? It's just easy. We just take the different sieves and the collecting pan. We weight it when they are empty. Note that weight. We start the sieving process. Again, we have to weight the different sieves, and the difference, of course, is now my remainder, my fraction, my sample on that specific sieve. So larger than 45 microns, larger than 4,000 microns, and so on. We know the total amount of sample, 150 gram in this example, which means this is 100% sample, and 3 grams of this fraction, 3 grams of 150 gram means that's 2% of the sample is yeah larger than 4,000 micrometer. And so you can just calculate the particle size distribution manually, or you can use EasySieve, the software which calculates it automatically and also can be connected to a balance, and then all this weighting is much easier. Three examples are left over for sieving. Here the customer asks us, hey, we have to do incoming inspection of cereal flakes to determine the quality. And for us, it's very important to see how much powdered particles are in that material, in the raw material, because the powder disturbs tight sealing on the packaging and also has negative effects in some crunchy products. So we have to avoid that. And the customer is very satisfied with the AS200 control with standard sieves, mesh sizes for 500 microns to 4 millimeter, and just set the amplitude to 1 millimeter. And in 5 minutes sieving time, we were able to separate all the fractions and to determine the fine fraction. And then the customer can say after 5 minutes, okay, this is good raw material, or maybe refuse a raw material which is too powdered. Another question was, hey, can we somehow separate these ingredients of this nut and seed mixture? Here we try to use AS400 control, which has a horizontal movement, so it doesn't throw the sample just in the air by some impulses and 3D movement. It's just shaking and horizontally, which is usually quite nice for such shaped particles, flat particles, flakes, and so on. Yeah, separation worked semi good. So you see the largest particles we were able to separate, also the fine nuts and seeds, but in the middle fractions we had still the mixture because the size and the shape was too similar to be separated by sieving. So maybe for such a question, sieving is not the best option. It depends on the requirements, what the customer really needs, on how the sample is really or which composition of the sample is found. And just for powders, like coffee, we also have some sieving systems like the AS200 Jet, which can be used with very fine sieves with smaller purchase sizes, for example, 0.1 to 4 millimeter. And here with an airstream and a vacuum, we are able to get the sample through this finely poured sieves. For ground coffee, that's fine. And here we can also distinguish between different types of coffee. In that case, customer wanted to see whether it's sort A or sort B, or type A, type B of the coffee. And they mainly differentiate in the middle fraction here. The first one has 50% of the sample distribution in the middle fraction, and the other one just 35%. And with this sieving process, the customer was just able to differentiate between the types of the coffee. So beside homogenization and sieving, I have one last point before we close the webinar. We can offer also something for extraction of pesticides, for example. The extraction of pesticides is usually done via the Caches method, where you mix the pulverized sample with 10 milliliter acetonitrile. And you also add some salts to prevent ghost peaks. And then you have to shake it rigorously for 1 to 3 minutes, or when you do it manually, maybe or even longer. And here the problem is, okay, when you shake it manually or put it onto a vortexer in the beginning of the day, okay, you're just fresh and you do it with nice enthusiasm. In the end of the day, you're maybe tired and you do not do it and with the same enthusiasm anymore. Maybe also the time is different. So the results will be different. And you can only use 1 or 2 samples in one go. Here with the MM400, with the Mixamyl and the Falcon tube adapter, which keeps 8 of the Falcon tubes at the same time, you can process 8 samples, and it's always the same mixing. It's always 30 Hertz for 1, 2, or 3 minutes what you set. And here you will have the best reproducibility with this automated system just in 3 minutes. And just for your example, when we compare the different qualities of plant sample, here ground in GM200 to 1 millimeter, ZM200 to 250 microns, or in the cryomill to 100 microns, then do the Cash's method, and then we see that the best yield is with the fine ground sample, which came from the cryomill. So here, indeed, also the grinding factor or the particle size influences, this extraction, and can help to come to better results. So now I'm at the end of the presentation. Just some words for the download package and further information. So in 1 hour you will receive the follow-up mail, and there are 2 links included where you can download all this information, also the presentation in a PDF form. This download package contains application reports and also our sample, which deals with food sample preparation. Several years ago, we have been also asked to write a book chapter for food sample preparation. This is included as well, and a lot of videos which can be watched them nicely. Yeah, and if you like to inform yourself, of course, our homepage offers you a lot of option about the different mills and types. And you are also most welcome to send us your samples just for feasibility studies so that we can give the best recommendation of mill equipment and time. For you, it's free of charge. Depends whether you send it directly to Germany or to your local dealer. But you will find all the information on the web pages and how it is done. And it's for us a pleasure to help you to find the best procedure for your samples. Of course, the download sections of the web page gives you more information, other videos, other mills which have not been taken into account into this webinar and so on. So at this moment, it's time for us to say goodbye. Thank you very much for participating in this webinar. So it was really a pleasure, and thanks for listening. Bye.